For now, let's take a look at the deck we're going to build. This is a medium-sized deck. It's large enough to accommodate outdoor furniture, yet small enough to keep the construction costs reasonable. It has 2 staircases to quickly access both sides of the yard. The decking, railing, and trim materials are synthetic products that will provide years of virtually maintenance-free enjoyment. A decorative double border accents the deck's perimeter. The deck's framing is pressure-treated lumber. A ledger supports the deck at the house. 2 beams support the joists, and a total of 8 concrete piers centered under 4x4 posts carry the weight of the deck. Before we get started, we'd like to say a word about safety. Both your safety as you build a deck and the safety of those who will enjoy the fruits of your labor. Decks are often subjected to considerable loads during a party, so make sure that yours is built properly. In most areas of the country, decks do require a building permit to ensure that they sit on an adequate foundation, are built properly with rot-resistant materials, and are attached securely to the house. As you watch this video, you'll see this icon pop out. This simply identifies a critical point where you should check that your deck conforms to local building code. As for personal safety, be sure to use safety glasses when cutting and nailing. Wear hearing protection when called for, and be careful when working from ladders or framing from an unfinished deck with no railing.
In preparation for the new deck, we removed the old deck and the old deck ledger. You always inspect beneath the ledger of an old deck because 9 times out of 10 you're going to run into some sort of rot or moisture problem that occurred with the old deck flashing. And this was no exception. We pulled this apart. The sheathing was a little bit rotted, so we cut the sheathing off, and underneath we have a nice rotted section here in the corner.
The most important thing to do is to identify the source of the moisture infiltration and correct it. Repairing rotted or damaged house framing is beyond the scope of what we can explain in this DVD. However, when building a new deck, we often get the opportunity to peek under the hood of our house. Most of the time, we can spend a little time to repair the damage and then move on. If you do find significant damage, then you may have to address that before continuing to build your deck. After repairing the rotten section, we used 1/2-inch construction-grade plywood to match the sheathing on the rest of the wall. The new sheathing butts into the old sheathing at the top and hangs down about 2 inches over the cinder block foundation along the bottom edge. To prevent moisture migration from the foundation to the sheathing, I make sure that the sheathing doesn't actually come into contact with the foundation. Check with your local building department to ensure that the replaced sheathing and nailing schedule conform to the structural requirements in your area.
I'm marking the sill, and I'm marking the bottom plate of the wall because I want to make sure that any nails that go through don't hit into any plumbing or any wiring. And if I hit the bottom plate and I hit the sill, I know I'm going to go into solid wood, whereas if I'm going through the band, there's always a chance of a wire being right up against the band there and the nail poking through just enough to short it out. So just want to make sure that the surface underneath the ledger is flat and tight to the framing.
After the plywood goes up, we want to shift gears and get our pier forms installed so we can get concrete poured as soon as possible. To establish the pier locations, we first need to mark out the perimeter of the finished deck and work back to mark and dig the pier holes, which are centered under the deck beams. From the inside corner, I measure and mark the 20-foot length of the deck on the side of the house. From there, I plumb down to mark the location on the foundation at the ground. We measure out from the wall 20 feet and then drive a stake. We measure out 20 feet to represent the other side of the deck and drive another stake. Next, I adjust those 2 outer stakes until they are exactly 20 feet apart. To make sure the deck perimeter layout is square, I measure diagonally in both directions. If one diagonal measurement is longer than the other, I adjust the corner locations until the diagonals are equal, and then the perimeter is square. Using the location of each end of the ledger that will connect to the house and at the stakes we just pounded into the ground, we can string the deck's outside perimeter. I like to use a bright string that is easy to see in the grass. It's far too easy to trip over the string and move the stakes, undoing all the measuring work I just did.
I'm stringing up a reference line so I can locate the posts which sit directly beneath the beam. The reference line is going to go exactly in the center of the beam and therefore exactly in the center of the post as well. I'm going to use the outside perimeter of the deck to measure back to locate the beam. The beam is exactly 3 feet 6 inches, so I can slide this line back and forth until I hit 3 feet 6 inches.
The metal batter boards we are using for this project were purchased at my local tool supplier. However, it's easy to build a batter board assembly using some scrap lumber on site. The benefit of using a batter board over a stake is adjustability. I can fine-tune the string placement without having to relocate my stakes. A batter board also enables me to reposition the string exactly to the same spot to check my pier locations once the holes are dug.
All right, hold that back.
I mark the pier locations with surveyor's paint that you can buy at most home centers. I mark the center first, then roughly locate the perimeter of the hole.
So now we remove the strings and dig the holes. And I say we. This is the easiest way for me to dig a hole. Here we go. Okay, the rest is for the post hole digger.
Cylindrical pier forms come in diameters ranging from 8 inches up to 24 inches or larger. They are widely available in cardboard, but if you think your forms will be exposed to the elements before the concrete is poured, plastic forms can be special ordered. The forms can easily be cut with a circular saw or a handsaw.
All right, we've got concrete that's going to be here in about 20 minutes. Big concrete truck coming. It's off by about 3 inches, 4 inches, just like that one.
Concrete piers transfer the deck's weight to solid ground. To do so effectively, they need to extend below the frost line and any backfill that may have been introduced. A typical pier consists of a cardboard form, concrete, and an anchor bolt. The size of the pier will be determined by the deck's engineering.
There's concrete. Yeah, can we fake it? You know, just grab the edge. Yeah, right on the top. Yeah. Oh, shoot. No, I think we have to go that way. There's just that hump there. Okay, you want to backfill around this one? I'll hold it in place.
When it comes to pouring the concrete for the piers, I can either mix it myself from bags or I can order it from a concrete company and pour it from one of their trucks. If there are only a half a dozen or so piers and no landing pads, I generally have the lumberyard send ready-mixed concrete bags to the job site, and then when I'm ready, I'll just add water and pour the piers.
You can take a lot less than that. This is my wife's wheelbarrow. We ruined the others. Why don't we just bring it over here? I'll spoon it in. Whoop, back up a little. Yep.
But when the volume of the concrete needed approaches or exceeds 1 cubic yard, which is usually about a dozen piers, then I call a concrete company. Most concrete companies have a 3 to 4 yard minimum. This means I get charged a minimum even though I might only order a yard or so. But I can usually get a break on that minimum charge by putting in the order first thing in the morning. That lets them come by when they have extra concrete left over from another job. There's plenty of other work that needs to get done before I need the footings anyway. The top of the piers only need to be roughly the same height. Later we'll make up any height differences by cutting all the posts to the same elevation using a laser level.
You really don't care too much. All you have to do is float it till the cream comes to the top and the aggregate settles, something like that. It's a footing, as long as the center.
The basic framing we need to construct first consists of piers, posts, and beams, as well as the ledger that's attached to the house. We'll install the joists in the next chapter. Right now, we'll start by installing the ledger against the house. Then we'll cut the posts to the right height and attach them to the piers with the hardware that we drill into the concrete. Finally, we'll assemble the beams that carry the deck joists. The first task is to apply the self-adhesive flashing against the sheathing we installed yesterday. This flashing protects the house against any moisture that might migrate through the support ledger and potentially cause rot. There are several different brands of self-adhesive flashing. This particular product, called Grace, comes in 12 and 18-inch widths. It readily sticks to the wall, yet is easy to work with. I like to use the roofing detail membrane when flashing the wall because it is thicker and has a less aggressive adhesive. Later, when we flash the top of the joist, we'll switch to the decking membrane.
You might want to cut that before you...
As with any flashing, the top edge of the membrane should lap under any flashing or house wrap above it. After the first layer of flashing is applied, we are ready to locate and install the ledger board.
Okay, we're stepping down the deck 4 inches here to prevent any ice and snow that builds up through the winter time from going up underneath the sliding glass door. I've set up a laser transit over there which emits a level laser beam. This receiver measures it until I hit it right dead center on the level. And I tighten it at that spot. And now I know wherever I go, I'll have the correct elevation.
I mark the top of the ledger height at the furthest point along the wall that the ledger extends, and at the inside corner of the house. I snap lines in between these 2 points to indicate where to install the top of the ledger board. We locate the ledger board and tack it in place with a few nails. Once positioned, we can secure it permanently using 3 1/2 inch by 1/4 inch ledger lock screws that can be driven home with a common impact driver. The deck ledger must be secured with screws or bolts. Simply nailing a ledger in place is insufficient. As you can see, the ledger that runs underneath the sliding door extends beyond the corner of the house a considerable distance. For now, we'll let that end run long and cut it to length later.
Yep, just work it from the corner.
Over the top edge of the ledger, we apply another layer of self-adhesive flashing membrane. Over that, we install copper flashing that we purchased from our local roofing contractor, who bent it to fit our ledger detail. This can also commonly be ordered from your local sheet metal fabrication shop. Again, to ensure that the moisture is directed away from the house, the top edge of the copper flashing laps under the house wrap and siding above it. This detail cannot be overemphasized. Once we flash the ledger, we can move on to assembling the beams. The top of the concrete piers can provide a handy work surface, so before I install the support posts, I strip the cardboard off the forms and assemble the beams right on top of the piers. Once assembled, I can set them aside until the posts are installed and the beams can be set on top. These beams, as called out on the plans, are too long to be assembled with lumber that span the whole length. By assembling the beams on the piers, I can locate my joints directly over the posts without having to use a tape measure. If you're using 3 1/2 inch framing nails like we are here, be sure to angle them so the sharp end doesn't protrude from the other side. Also, driving a few nails in the opposite direction locks the framing lumber together better than simply driving them straight through. At the ends, where the beam is close to the edge of the deck, I clip the lower corner to reduce the chance of giving myself or one of the crew members a headache. I snap lines across the tops of the piers to locate the center of the post bases. To secure the post base, I drill a hole for the concrete hold-down screw.
I'm using Titan HDs here instead of anchor bolts. And the difference is we can put them in after the concrete is cured, snap the lines, locate the holes, and then drill where we need to, rather than with anchor bolts where you have to locate them exactly while the concrete is wet and put them in place. This gives us a lot of play with where we can place these on top of the footing. I've set the transit back up so that we can determine at what height to cut the posts. To do that is very simple. I simply slide this up to the bottom of the ledger, which is also the bottom of the joist. Slide the receiver up until I get the single pitch. And then once I have that pitch, I lock it in place. Now I know that's the bottom of the joists. Beneath the joist, we have a 10-inch 2x10 beam, which is 9 3/8 of an inch. So to get the top of the post, which is also the bottom of the beam, I slide this up 9 3/8 of an inch. And now when I move this into position and I get the steady signal, that's the point at which I cut the posts.
In wet climates, the copper in common pressure-treated lumber will corrode metal. To protect the deck's connecting hardware, I apply a layer of flashing membrane between metal and wood connections.
Yep.
To ensure the posts are fully seated in the bases, I plumb them before driving any nails. This pneumatic nailer has a tip specifically designed to locate nail holes in connecting hardware. Do not use a standard nailer when connecting hardware.
Can you lift your end up? Yep.
Good.
That's where it goes. Let me get this set. Yep, down. Beautiful.
As the support framing goes up, we check it for plumb, level, and square.
Grab hold of the beam, the post, and move it.
Then we brace it temporarily with 1x scrap lumber. With the post, beams, and ledger in place, we'll start by installing the rim joists on either side of the deck. Then we'll mark the joist layout on the beams and ledger. Next we'll attach hangers to the joists, then fasten the hangers to the ledgers. We'll snap a line and cut the ends of the joist to install the outer rim joist. We'll nail in the ladder blocking that will support the picture frame border around the decking. Then we'll bolt newel posts in place. We string a line 2 inches off the first joist that doubles as the ledger against the house. We can then measure back to the board along the string to ensure the board is set straight. Once straight, we tack it in place. To protect the joist hanger from corrosion, we wrap the end of the joist with a flashing membrane. I like to attach the hanger to the joist first, then make the connection to the ledger. I find there's more room to maneuver the nailer if I'm working off the lumber stack or a set of sawhorses. Again, I use a pneumatic nailer specifically designed for hardware such as joist hangers. Before I install the joists, I need to mark the joist layout on the ledger and have it match the layout on the beams. To do this, I establish the deck center point on the ledger and the beam farthest away from the house. I can then snap a reference line and pull my layout from that. This method ensures that the layout marks on the ledger and both beams match exactly. The deck plans call for joists laid out at 16 inches on center. This is typical, but if you're using a composite decking material, check the manufacturer to make sure that the span rating matches your deck plans. Also, if you're going to put something heavy on the deck, like a hot tub, you want the deck framing to be engineered or at the very least checked over by an architect. Using straight or slightly crowned joists is crucial to building a flat deck, because the last thing I want is to have the deck tables and chairs wobbling on a very expensive brand new deck. It's a good idea to double check the crown of the joist as you're installing them, because occasionally a bad one can slip through.
You see the crown in this one? Oh my God, it matches this one.
I check the joists by sighting along the top edge. I cull out the ones that have more than a 1/4 inch crown. The ones I cull can be used for shorter runs, but if they are really bad, I just send them back.
Move your hand. That one's okay. Nope, that's out. It's got a big dip in the middle.
To make sure I don't run short of good joists, I usually order about 20% more than I need. I can send the bad ones back to the lumber yard after the job is done and get a refund.
Are they heavy?
Every once in a while, I'll get a load that contains too many unusable joists, which puts a stop to the project until I can get new lumber. The other reason why I fasten the hangers to the joists first is that it's easier to align the tops of the joist flush to the top of the ledger. Where the stairs interrupt the joist layout, we simply header across the top of the stairs and continue the layout. The rest of the joist attached to a rim that runs parallel to the ledger. Here's a little trick for when you need a third hand to hold the end of the board. Simply pound a nail halfway into the top and bend it over. The nail catches on the adjacent joist and keeps the top flush.
Yep, right there.
And all right, we have the joists all the way up from the house all the way out. They're not fastened to the beam yet. Before we fasten them permanently to the beam, we're going to fine-tune the posts to make sure they're exactly plumb. Make a mark. And now I can fasten the joist to the beam which holds the post plumb.
Now I'm going to run a string line all the way down to straighten the beam before we nail the rest of the joists on. I use 3/4 inch blocks to hold the string off the beam at each end. Then I check the beam for straight using a third block.
That's right where we want to be.
To attach the joist to the beam, we simply secure them with right-angle brackets. Now that the joists are in place, we can cut them to length. To do this, I snap a chalk line across the joist I want to cut and then square that line down along the side of the joist. To get a straighter line for our rim joist, by marking and cutting joists after they've been installed rather than trying to measure and cut each one while still on the sawhorses.
Now you're going to lift it way up, AJ. Lift it up. Just slide it up. It's got to go way up. All right, let me nail the top in. All right, lift it up. Up, up, up. A little more. Right there, hold it. Can you tell this one's racked a little? Okay, down. Bring it down. Down. Hold it. Back up. Right there. Way down, way down. Whoop, up a little. Good, hold it.
Now I'm ready to cut a 45-degree corner off the end of the deck. All I have to do is draw a line across these two inside points and snap it on the intermediate joist. Draw the line down, then cut the joist with the saw set at a 45-degree bevel. Then put the band joist in place to complete the corner.
Let's see if this puppy fits before we do anything stupid, huh? I have to push it that way. Pull the bottom in. All right, let me see how well it fits. It's got to be perfect, right? Let it in a little bit, yep. Don't worry, I haven't shot anybody else yet except for myself.
To keep the deck from racking over time, we need to secure it permanently with knee braces between the support beams and the posts. The knee brace is simply a length of 4x4 post material with 45-degree cuts on both ends. The overall length is just over 2 feet. I use long 1/4 inch timber lock screws to secure the knee braces.
No. Yeah, just put the one up against here.
We've installed the posts temporarily plumb. To make them permanent, I'm going to use this metal connector. This is going to bolt right through the post to the outside band. The reason we need this bracket in here is because there's so much leverage at the top of the post, it will prevent the post from being pushed out and racking the outside band. For the areas with ladder blocking, I use the same hardware, but I add in another bracket to lock in the adjacent joist.
That's it. For this deck, we're using a 5/4 by 6 PVC deck plank. It has a wood texture on the top, grooved edges on both sides. The grooved edges are used in this case for a hidden fastening system. There are a number of concealed fastening systems out there. This is one that's proprietary to this particular deck style. The clip slips into the groove right over the joist location, and the stainless steel screw fastens it to the joist. And then the next plank clips onto this little extension here and continues the process. There are times that you can't or don't want to use a concealed system. The part without the grooved edges is for exposed parts like the outside of the deck, the edges of the stairs, or any other part where you don't want to see the groove. In that case, we use stainless steel fasteners with colored heads.
We establish our first decking layout by pulling a straight line off the edge of the stair opening. This enables us to have a full board with that proper 1-inch overhang along the highly visible edge. We then measure back to the house and rip that first board to the layout. Under the sliding glass door, we decided to install the border deck boards first to allow ourselves enough room to scribe the first one to the wall of the house. This doubled up border runs all the way around the deck like a picture frame. Next, we install the field decking, butting the ends to the border with the appropriate gap. When installing the field decking, we let one end run wild. We can cut it to length in place. Then we install the border pieces. Finally, we'll install the border and the decking for the 45-degree clip corners, scribing the border around the newel posts. The last thing we need to do before we start fastening the decking down is to apply strips of adhesive membrane to the tops of the joists. This helps to keep the moisture from migrating through into the wood through the fastener hole, which could cause rot. When snapping a long chalk line, like the one at the edge of the stairs that establishes our decking layout, I'll hold down the line in the middle and snap both sides. This generally gives me a straighter line than if I try to snap the whole length at once.
Measure to the wall.
Under the sliding glass door, we decided to install the border deck boards first to allow ourselves enough room to scribe the first one to the wall of the house.
Let's all, AJ keeps ahead of us, we're all set. So we don't have to bang the whole thing all at once. We can work the way down, or we can just bang it in. Let's get a good sweat going.
I've got the handle up top here.
No, I have the handle. We're looking for the head.
Oh, I got it right here.
Mo, Larry, Mo. Yeah, yeah, yeah. I got it. You don't have to push it up. I got it. Yeah, here. Step aside, coming through. Whoop. There you go.
When cutting the decking back to allow for the double border, we snap a line the appropriate distance back from the edge of the deck and cut along that line with a circular saw. Be sure to adjust the saw blade depth so that it doesn't cut into the framing. We've had to alter the framing a little bit by putting ladder blocking in between the last joist and the band joist.
Down here, we cut a 45-degree angle off the corner of the deck. Double band is going to come down, make the first cut here. It's going to be a 22.5-degree angle. When we get to the other corner of the 45-degree angle, it'll be another 22.5-degree angle. Then the band will continue parallel with the rest of the decking.
Scribing the border band around the newel post slows things down a bit, but luckily we have some allowance. The white sleeve over the newel post will cover up to a 1/2-inch gap around the base.
How about we measure, so we're not waiting. I'm burning an inch. This is too long, I'm gonna scream. That's right. Down. Ah! I'm gonna take a blade off of this. Back here. I've done this before. Good.
With the last of the decking in place, we can install the railing system, but first we need to build some stairs. The most common style of deck stairs is a short straight run of open stairs using notched stringers. This is also probably the simplest kind to build and what we are going to build for this deck project. To lay out and cut the stringers, we need to calculate the rise and the run for our stairs. Level over from the top of the deck and measure down to where the stairs will land. This is the total rise. Divide the total rise by a comfortable height for each riser, in this case 7 1/2 inches. Our result is 9 risers plus a little. We'll deal with the remainder in a second. Multiply that 9 by the run, in this case 10 inches. And we determined that the stairs will land 90 inches from the edge of the deck. Now take the remainder we got a second ago and spread it out evenly among our steps. That adds a 16th to each step. We now know that we have 9 steps that are 7 and 9/16 inches tall. At the top, we'll attach our stairs to the band joist with 4x4 blocking. We'll land our stairs on the temporary paver blocks that will eventually be replaced with a concrete landing pad. We'll incorporate a kicker board at the bottom to attach the stringers to the landing pad. This prevents the stair stringers from kicking out. Now that all the hard work is done, let's build some stairs. The first step when building deck stairs is to take a rough measurement from the top of the deck down to about where I think the stairs will land.
Flip it over.
To do this, I need a long level,
Measuring to the bottom.
or a level with a long stick. Once I know where the stairs will land, I can install a landing. For now, we'll use some concrete blocks to temporarily support the stairs until a permanent landing is constructed.
It's important to try to figure out exactly where the landscaping will come up. It rises up a few inches over there, so I'm figuring this block will be the height of the finished landscaping.
Once I get an exact measurement to the landing, I can calculate and cut my stringers.
Now I'm going to cut the stringers to the stairs. Before I do that, I have to mark them out. We've already established that our tread length is going to be 10 inches. So I'm setting this piece of wood, the outside edge of the piece of wood, on the 10-inch mark of the framing square. And our rise is 7 and 9/16. Start down at the bottom end of the stairs and just work our way up. Now there's one last adjustment I have to make before cutting the stringer. Okay, this is our first step. And like all the others, it measures 7 and 9/16 rise. Now if I cut it like this, we'll have our decking sitting here for the tread. That's where our foot goes. What I have to adjust is cutting 1 inch off the bottom of the stringer. So now all I have to do is, this is my original line, slide this up until I have the 1 inch mark right here. Now I'm going to cut the bottom of the stringer right along that 1 inch mark. This measures 6 and 9/16. When I put the tread on, it'll be 7 and 9/16, exactly what we want.
When cutting the stringers, I'll cut all the stairs in one direction first, being careful not to overcut the inside corner. Then I'll cut all the stairs in the other direction. Finally, I'll use a reciprocating saw to finish the cuts. When I get the first stringer cut, I trace the outline to the second and third stringers. This will keep them as consistent as possible. Finally, I'll cut the bottom of the stringer to accept the kicker board. The kicker can simply be nailed in place. At the top, we'll use adjustable metal connectors to attach all 3 stringers to a length of 2x. Then we'll secure that to 4x4 blocking behind the deck band joist.
All right, I finished framing the stairs, putting the stringers together and securing them at the top and the bottom. The next step is to trim the stairs before we put the treads or risers in. This deck is getting a piece of trim all the way around the band and then down the sides of the stringers. So rather than cut the profile of the risers and the treads out like you see on interior stairs, we're just going to leave it housed in like this so that the treads and risers will fit inside of the 2 pieces of trim. This gives a nice clean look on the outside, which continues down the sides of the stairs.
With a skirt board in place, I can cut the treads to fit and screw them down. Building deck stairs doesn't have to be complicated. I've seen pre-cut stringers at the home center, but to me they are more trouble than they are worth. With just a few measurements, I can cut stair stringers on site and have them up in the time it would take for me to go to the store and buy some. Like the decking, the trim elements of this deck are made of synthetic materials. We used 1x10 trim boards to cover the band joist and a manufactured composite railing system that is assembled on site.
Most of the proprietary systems are already incremented at 4 inches, just like this one, because that's the code. And most of them that I've seen also do the same thing. You start from the middle, you measure out, and you have your offset on either end. It's not going to be exactly 4 inches, but that's equally divided on either end. This has a top rail, has a bottom rail that will go on here, and that's what this is. So AJ is screwing on the balusters onto the bottom rail at this time. So don't let me stop you.
The railing system we chose consists of sleeves that fit over the structural pressure-treated posts that we installed during the framing process. A decorative collar slips over the sleeves to dress up the base. To install the railing, we fit the sleeves over the posts and shim them plumb. Then we attach brackets to accept a bottom rail that the baluster assembly clips over.
Boy, I'm really cleaning up on this job.
Because they are pre-painted, it's a good idea to take a little extra time while marking, cutting, and fitting the pieces to ensure the finish isn't damaged.
Putting the band around the outside perimeter here, we have to deal with these 45-degree angles on both corners of the deck. And one little trick for getting the measurement of this corner and cutting it precisely is to first cut a couple of extra pieces of trim, 2 pieces, 4 inches, and I beveled it at 22.5 degrees on both edges. To find out the location of where it exactly comes together, and then I just draw a line on one side and then the other. Now I simply measure from my last piece to that line, which is exactly 59 inches, and I add the 4 inches, which gives me 63 inches from the flat part of the cut to the long point of the 22.5 degree bevel.
Into the crank line.
To make a straight cut without a miter saw, I use my speed square as a saw guide.
We're just tacking it up right now with the gun. Later on we'll use stainless steel screws to put it in permanently.
At the miter joints, we apply a bonding glue to help hold the PVC pieces together. The baluster assemblies fit over the bottom rail that we installed. At the top, they attach with a bracket that fastens to the post sleeve. At the 45-degree corners, the ends of the baluster assemblies are cut so they fit centered on the post sleeves.
Yep, slide it down. Yep, slide it. Hey, there we go. All right, we finished.